This video is going to walk through what's called, uh, what we refer to as mistakes within testing. So our overall objective here, we want to be able to know there's two types of errors that can happen when we run a test. And these errors are actually related to that alpha level, that cutoff level that you guys have been talking about. And then also we're going to talk about something called power of a test, how good a test could be. So let's say a person's on trial for committing murder. So what are the possible hypotheses our lawyers could argue? Well, the null hypothesis, right, in the American court system is that you are innocent until proven guilty. So the null hypothesis would be innocent. And then in this trial scenario, the alternative would be that you are guilty. So there is a possible, right, once the jury reaches its verdict, it's not 100% sure they made the correct decision, right? There's always some doubt in somebody's mind, even if there's a videotape of the person doing it, right? There's always somebody arguing it. Maybe it wasn't them. Maybe it wasn't them. But there are some possible mistakes they can make, and those mistakes could be consequential. So one possible error, they could find the defendant guilty when they are actually innocent. So here's the first possible error that someone can make, right? They could find the defendant guilty when they are innocent. Does that have a consequence? Well, if you think about it, right, is there a consequence to this action? Right? If you find somebody guilty when they're actually innocent, you just sent the wrong person to jail, right? Now, what's scenario two? Well, they could find the defendant innocent when they're actually guilty. There's also a consequence here, isn't there? Now, all of a sudden, what have you done? If you're on that jury, what's the consequence here? You just set a criminal free. Um, so, in a more, this is a very general kind of idea to get the ball rolling. But as we kind of start going through this, there are two types of errors, and we just discussed both of them. A type 1 error is when you reject the null when it is true. In other words, we found the defendant guilty, right? We rejected the null, right? So we rejected that they were innocent, but they actually were, right? The other type of error is a type 2 error, right? That's when we failed to reject the null. In other words, we thought that they were innocent when in fact they weren't. So what ends up happening when you do a type 1 error, you reject the null when you shouldn't, right? And there's an arrow on your note sheet right there. You reject the null when we shouldn't. If you commit a type 2 error, what's happening here is that you're going to fail to reject when we should have. In other words, we should have said they were guilty. We should have rejected the null hypothesis of innocence. Now, there's a lot flying around right here. So this table at the bottom of your page is going to be the best way to kind of keep everything straight. So you basically have two things happening. If you put along the top the truth, this is the actual truth. There's two options. Either HO is true, the null, or you could also write that as the null is false. Right? This would also be HO, the null is false. Right? If you want to write it that way. So there is an absolute truth out there. We don't always know it, right? It does happen or it doesn't happen. And then on the left side of this table, you're going to write your decision. Well, we've always got two decisions. We either reject the null or we fail to reject. So if we reject the null, but the null was true, that's a type 1 error. Now think about this. If we reject the null and it happens to be false, so we're sitting here in this box right here, if we think about that for a minute, that's a good thing. If we reject the null when it was false, that's a good thing. And for us, really another way to really look at that, that just means you made a good decision. Now think about this. Let's say that we fail to reject. If we fail to reject the null and it happens to be true, think about that. We failed to reject it and it was true. In other words, we went with the null and it was true. Again, hey, that's a great decision on our part. Good job us. Looks like we came to the right decision. However, there's always a chance if we fail to reject, in other words, we went with the null, right? So we're looking at this box right here. If we fail to reject the null, when in fact it was false, that's where the type 2 error comes from. So if you can kind of, let me erase all my markings on this thing. This table has proven to be kind of the go-to way for a lot of people to understand and to get the right type of errors uh, in the right place at the right time. Uh, so for us, if you flip to the back of that page, according to the U.S. Census Bureau, 10.2% of registered births were teenage mother. Sociologist believes this has increased. So first thing we need to do is make sure we write our hypotheses. So the claim was 10.2%, and it's a P, right? This is a proportion problem, right? There's a proportion. And we think that this proportion or percentage has increased. So in other words, the alternative is greater. So a type 1 error, right? This is you reject null, and null is true. Sorry, I'm having to kind of write on this with my keypad. We're going to reject the null, but it's true. So in other words, right, so the null is actually true. So for us, we would decide the percentage of births is greater when in fact it is equal. A type 2 means we fail to reject. So in other words, we're going to claim that HO is true when in fact, right, you failed to reject. So we're going to say it hasn't increased, but actually it has. The next example, according to the CTIA, the mean monthly cell phone bill was $49.94 in 2007. We got a null hypothesis. It's an average. A researcher suspects this mean is different. Doesn't give us an up or down, so that's just not equal to. So type 1, we're going to reject the null. In other words, we're going to claim the alternative. We're going to say it looks like it's not $49.94 when in fact it is $49.94. A type 2 error, remember we're going to fail to reject the null, which means we're going to go with this statement right here. We're going to say it is $49.94 when in fact it is not. Measuring mistakes. So the probability that we have a type 1 error. In other words, the probability we reject HO when the null is true. So the probability we reject the null when it is actually true. That's the alpha level, right? That's our significance level, our cutoff level. We've been talking about that throughout this particular unit. The willingness, basically the alpha level, that's how willing we are to make a mistake, right? So when we do a significance level of 5%, they're saying, hey, we're willing to take about a 5% chance that we're wrong, right? That's why a lot of times in a lot of research, they drop that alpha level even further down to like 1% or below 1%, you'll see sometimes. The probability of a type 2 error, in other words, that you fail to reject the null, given that it's false, is actually beta. The good news is you guys aren't going to actually have to calculate really any of this stuff or do any kind of crazy math. You'd just be asked, you know, what is the alpha level? Well, you're just going to go to the significance level. A lot of times this beta level is given to you. And if not, I'll show you in just a minute how it is plays out. So what you have to realize, though, as the level of significance, as alpha decreases, the chance that you make a type 2 error increases, right? So basically, as the probability that you make that alpha type deal or alpha type mistake, as that goes down, the probability that you make that type 2 error goes up. So these two things kind of have an inverse relationship, right? If you wanted to, you know, if you want to lower the chances that you incorrectly reject the null, you're going to have to decrease one, but the other type of error is going to increase, which means you could incorrectly fail to reject the null. It's kind of a weird way to think about it, but it's kind of a hard thing to explain. But if you think about it for a few moments, it kind of makes sense that there's this inverse relationship. As one type of error decreases, the other type of error increases, and vice versa. So if you want to decrease both errors, the best way to do that, and we've seen this a lot, if you're going to if you want to make your studies and your sampling and everything, increasing the sample size is the best way to fix pretty much any problem you have, statistically speaking. So how power works for us, that last piece on the sheet, power of a test is the probability that you correctly reject a false null. In other words, that's what's connected to your beta. So this is essentially the only type of calculation you're going to have to do with either one of these. Sometimes you'll be asked, what is the power of this test? And they're going to give you the beta level. You're not going to have to go figure it out. They're going to say beta is blah, 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 and you literally just subtract from 1.